Hello. I have a slight problem here. You know that I'm Brazilian and Italian, and I need my hands to speak. Right? So now I cannot speak. So, if you tie my hands, I can't speak at all. So I'll do it best. I don't trip on the wires. Yeah. So yeah, I'm very happy to be in Barcelona again. So I really like coming to the city. So also, I really like the Crafstmanship community here. I've been following that for quite a long time now. So I hope to be here for the conference in September. October? First and 2nd of October. Yeah, I'll do everything that I can to be here as well. And there is some news from our side. We are coming to Barcelona as a company as well. So Codurance will be opening an office here in the city, and we should be fully operating in kind of 2-3 weeks. So that'll be really cool to be hopefully working with some of you. Right, so, right. Yeah, this won't work well. I need my hands, I need to move, right? So what is this about? So for quite a while, I've been thinking about how I design applications, and quite often when I get to a new code base, I would really like to just go there and understand what it does without too much help. And so I spent like quite a few years like trying different approaches and stuff. So first a disclaimer. Right, so I'm gonna share with you some of the techniques that I use, but very important, this is not a prescription, because some of the things that I will present here today worked really well in certain applications and was a terrible idea in others, right? So no design solution will ever stand the test of ifs. As soon as you talk about what if, blah, blah, yeah, the design is invalid, right? So design is only valid within a certain context, right? So I'm going to share some general techniques that I use, but it will be up to you to say, okay, that's the context that I have, and this is all bollocks, right? That doesn't make sense to me whatsoever, or some of you may make sense. So yeah, don't say, oh, that's awesome, or that's shit, right? So it may be shit. So what was my goal? My goal was like, I have a new code base, I went to a client or a new software. I would like to very quickly, if I just open the code base, look at the structure of the code, right? Open a few packages or folders or stuff, and be able to answer simple questions like, what is this application about? Right? What does it do? And if I had to add a change, or if something is broken, or add a new feature, where should I go? But I don't want everyone to be there holding my hand. I just want to see that, right? That's what would be the least that I would expect from a well-designed software. It turns out it's quite complicated. Like even the ones that I was designing, I couldn't do that myself in my own applications, right? And I was thinking like, why I can't do that? And the reason, there were a few reasons. Like, one is because like badly structured packages or namespaces, right? So the way that the things were organized was not matching the business, right? So there were like an entanglement of things. So there were loads of architectural and design concepts mixed with business domain and stuff. So I was speaking to business product owners, and they were talking about features and business, and then I was looking at the code. So like, where the hell is that? And there is this factor and service and blah, blah, blah. So yeah, all entangled. And then, so well, just look at the code, right? So yeah, of course, but in a large code base, if you look at the class and methods, they are too low level. Because even if we design our classes very well and our methods very well and we name them very well, that's great when you have a small application. But think about enterprise applications with hundreds of thousands of lines of Java and C#, right? So I'm not going to read all that code. And then so, oh, just look at the test, right? That's the normal answer. Good luck with that, right? So first of all, be happy there are some, right? And then when there are some tests in there, good luck understanding them, right? So it's not that simple, right? So, and then, so I'll give you some examples, and these are all things that I did myself, right? So for example, how many of you structure your applications somewhere along these lines? Don't lie to me, right? If I go to the code base, I'll see something like that, I'm pretty sure, right? So your controllers, your reports, with your factors, your helpers, right? I've done that a lot, many times. It's cool because as a developer, I say, wow, I have shitloads of layers in there, right? That's awesome. So, and then I said, wow, if I want to know where my parsers are, I can definitely do that, right? So let's speak to a product owner about parsers. And so like, but what does it do? What is this application about? Probably not about helpers, right? Or managers. There's no YouTube in there. See, I was not that bad. There was no YouTube package or stuff like that. So, yeah, that bucket of shit that you don't know where to put stuff, you put in the YouTube, right? So that's what I use. So that was okay. So I could see some layers in there, but I could not see the domain, and so I had no clue. So I said, well, I had a great idea. So we should put some domain in there, right? So domain is important. So, and I said, okay, let's mix some domain here. So I said, oh, let's put some books in there and some users. And that became quite ugly now, right? So, and it doesn't matter which order you go. Like, you can put the domain in front of your layers, or after your layers, it will look ugly, right? But there was an improvement. At least I know what it's about. I know that there are users in the system. What's progress? There are some books in the system. That's also progress. So I know roughly what it's about. But what does it do? Right? Who are the users? Are they authors? What do? They buy books, they review books, they share books. What are the books about? Do we buy them? Do we share? Do we compare? Do you, I don't know, give for charity? Have no clue, right? Besides all the structure, there's loads of duplication as well. And you end up with packages. Now, with this approach, with sometimes one class in each package, or namespace, right? So that's another problem that we have in there. And this is just the two of nouns that I have in my model. Imagine like a complex domain, how many nouns and how many domain concepts you have. So the package structure in that, right? So this is another classical example, right? So that's awesome. So I have controllers, model, and view. That's progress. I now know there is a web app, right? That's awesome. So a lot of frameworks will, even like if you create with using a template, it will create this awesome structure for you, right? So besides being a web app, I have no clue what it does, what it's about. So I could explain to you exactly what I'm doing today, but that would spoil the whole thing. I will be just here for 5 minutes, and I need to kill some time. So I need to fill up with shit this talk, so I can be here for 45 minutes or so. So before I tell you what I'm doing, I'll take you through the thought process of what I took into consideration to start organizing my applications in a slightly different way. So yeah, all that thing sucks, all right? So how can what is important for me? So going back, I'll give an example of a web app because it's simpler to understand, but I was working in enterprise, so most of my applications didn't even have a user interface, right? But a web app is much easier to think about. So for example, one of the things that I was looking at is MVC. And MVC, for me, sounds very odd to talk about MVC in 2016, but it's still quite a misunderstood thing. So a bit of history. So, for example, starting in late 70s, 80s, just became a proper concept in 1988. I think that it was the Journal of Object-Oriented Programming. It was like something like that. And then they actually made it a term that they published. So, and then we had evolutions of MVC. We had like the three-tier architecture, and then we had like for people in the Java space, we said, oh, we should bring this MVC thing that is more like for the desktop applications to the web, and then you had the whole, for people old like me, they will remember Model 1, Model 2, that's when JSPs, servlets came about, the whole J2E thing came about, so that was, late 90s, early 2000s. And then there were quite a few evolutions or variants or flavors of MVC, like MVA, MVP, MVVM, quite common in the .NET world. I still don't get that. And the pack, and so there's quite a few of them, right? So it's interesting when you start looking at MVC, is how the type of client you have impact the style or flavor of MVC. So, for example, in a traditional multi-page web application, so you have a form, you click a button, goes to the server, does some stuff, comes back to another page and stuff. So the view is still your page, still your HTML, CSS and stuff. But your controller is on the server side, right? So the view sends an HTTP request, there's a controller there handling that, calls model, blah, 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 comes back. When you have a single page with Ajax or AngularJS or all this cool stuff, so you have you have more endpoints. There are still controllers, endpoints, but the page is smarter now. There's a lot of things going on the page, which means that the controller that's in traditional web apps, they were in the server. It's moving out to the client. So now the JavaScript on the page is doing more. There's doing the view and stuff, but there's also a lot of logic in there. There's some controller where to go and which endpoint to call and stuff like that. But that shifts also the design that you have in the backend, because the controller is now moving from one side to another. Console-based applications, right? So we still have quite a few of them, and the console is also a view and how it interacts with the application. So where is the controller? So there are, the way that you model that is quite interesting. Desktop applications. How many of you worked with desktop applications? Few people. So I worked with quite a few of them many, many years ago when I started. At some point I used to hate them because it was the whole swing thing in Java. It's horrible, horrible stuff. And since then, I never touched the desktop application again until a couple of years ago. It was one of the first clients that we had in our company. I absolutely loved to go back to this. And I tell you why. Because everything is there. It's a single user, single process, so easy to model. It's so nice. You have so much control in a desktop application. But in terms of MVC, it's still there, because MVC is a macro pattern. So, for example, each individual component, each your combo boxes, tables, buttons, and stuff, each one of them has its own MVC in there. So also the way that you interact with your MVC flavor changes. And then you have games that is quite crazy, because there's a low rate, it's very fast stuff. So the way to split view and controllers and models is quite complicated as well. And then you have all the other things. You can even, if you stretch your imagination, like in an enterprise application where you have services talking to services, you can even stretch your imagination that some of the services are the view or the client from other services, right? So you can even, but what I'm trying to say is that MVC is not that simple, right? So, and I had to think about that. Also, I also found like some bad implementations of it. Like, quite often we understand what view means, right? So very rarely we struggle to understand. So view, let's say, web app is your HTML, CSS, JavaScript, all that kind of stuff. And then because of bad frameworks, we learned that the model is our entities, right? So some frameworks, you just put some annotations in, it persists. How does anyone here work with Ruby on Rails? Okay, right. So for some frameworks, even in the Java space, call the model your entities, right? So your client, product, book, and blah, blah, they become your model. And Rails does a lot of that. Rails has these active records. But active record is an abomination of nature in terms of object-oriented. Abomination. Right? You have a thing that knows how to persist itself. It's an entity, a domain concept that talks to the database, does finds and stuff, all magically for you. Completely crazy. But so if your model is your entity, are your entities, your views are JSP, where does your business logic go? Then you have the fat controllers, right? Because like a lot of these web applications, you see these controllers with tons and tons and tons of lines because you have no idea where to put the logic. And so I see MVC as a macro pattern. And so for me, the view and the controller, according to how I'm delivering my application, right? So we have some business rules and we need to deliver that to the outside world, being a user, being another system. So the way that I deliver, that is called the delivery mechanism, that is where my view and controller lives. But if I have logic in my controller, then it becomes complicated if I have many clients, right? So probably MVC was not implemented properly. So what the hell is model anyway? So is it just my entities now? So the problem is that model is a very overloaded and confusing term because it means very different things to different people. So for example, is the M and MVC? Yeah, sure. But like some people say, well, it's the domain-driven design. Domain-driven design is model. Yeah, sort of. Like there is view model, data model, entities, active record, the combination of nature. But normally models are associated to persistence. And I completely disagree with that. So I normally prefer the view that my model in MVC would be where all my business logic lives. It's not about entities, it's about business logic, it's about behavior. It's all in my model, right? So how many of you are familiar with domain-driven design? How many of you actually read the book and didn't sleep and killed it? Yeah, it's boring as hell. But it's a fantastic book if you are able to keep awake while you are reading that, right? So there are very interesting things. I read like almost 3 times, I know. And every time I read it, I find more insights in that book. It's a fantastic book. But the second half is far better than the first, no doubt. Even Eric Evans that wrote the book said that the first half probably would do the other way around, right? But the building blocks don't get a lot of attention today in the domain-driven design world because they are not that great anyway. But at least gives you a flavor of what you could have in your model. I'm going to give you a quick domain-driven design in 30 seconds. So entities are classes that I care about the identity. So your products, your books and stuff. Value objects are things that will add attributes to an entity. So, for example, things like color, or size, or categories and stuff. I don't care about their identity, but they probably will add information to an entity, right? So that are value objects. I don't care about their identity, but I care about their attributes and stuff. So factories is a very funny one to be there because it has no domain meaning at all. But you may need factories. For me, this is the odd one out in the building blocks in the domain design. But depending on the object graph that you have in your domain model, you may need to have a place where you can construct that. And that's what the factories are doing there. I don't know. So repositories, basically they serve as a place to store data, or like they represent a collection of data. Not exactly store, but they represent a collection. Implementations may be stored. Services, there are 3 types. So application services, domain services, and infrastructure. So application services are classes that will control the flow of your application. Every reasonably interesting application will have a flow. As soon as you poke your application, it will trigger a series of events as a result of a single trigger. So the application service is the first class to receive that trigger and will control the flow at a high level. A domain service will be an entry point for a domain concept. So if you have like users, books, and stuff, every time that you want an operation in this domain area, you go for a domain service. That's the main difference between the two. Infrastructure are things that are important to your application, but are not necessarily part of your domain. For example, you need to send after a confirmation, after you paid something, you need to send an email. So you may have an email service there that is part of your business rules. You need to do that, but it's not exactly a domain concept. So it's an infrastructure type of service. So those are the main difference between the three. And aggregate is basically when you have a group of objects, I don't know, order item, and you need to keep them invariant. So you cannot go to the items without notifying the parent. So you always need to go through a root of an aggregate, and then the root of the aggregate will change the internals of that group of objects, keeping them invariant, right? So not allowing that to be an invalid state. So that's an aggregate. Oof, okay. So back to that. So now I realize that my domain model, actually my M is actually my domain-driven design, my domain model. And then this separation having the delivery mechanism and my domain model is very important. So when I design applications today, I keep that in mind. I keep this separation in mind. That doesn't mean that I'm going to split my application straight away, physically, as separate deployables. But I will make sure that my package structure or namespace, they will reflect the distinction between a delivery mechanism and my core domain, right? The reason that I want to do that is because it gives me flexibility in terms of how I deliver that behavior. If I will split them physically one day, I'm not sure, but I want to have that at least specified in the structure of my application. So if I'm working with a simple application, a simple web app, for example, the delivery mechanism becomes the application. And the domain model is deployed together with the application. But the deployment is part of the delivery mechanism, right? You can see that there is infrastructure on both sides. I will talk a little bit more about that, because both sides may need infrastructure. I'll try to explain why. So, but this is one of the options. If you have a simple app, you don't need to split it. The whole microservice bullshit is a problem now, because everyone wants to split everything, right? And as if it was the solution for all your problems. But it's important to have the option. It's important to establish the clear separations of responsibilities and wait your software to evolve and then decide if you need that split or not. Because as soon as you start splitting, you bring a lot of extra complexity, right? So if you need the split, if you have the different delivery mechanisms, and you have thought at least to keep like even at a namespace level, package level, you can wrap your domain model with infrastructure and then have as a separate deployable. And then you split the delivery mechanism. Because the view and controller that I was talking about from a web app and a mobile app is completely different. But I can wrap my domain model around infrastructure and then provide my ports and adapters, my endpoints, and all this kind of stuff. But I had the option, because it wouldn't be that hard if I had introduced that concept. So, and then of course, that once you have that, you are free to do all your microservices and all the things that you want to do, right? For whatever reason. So what does it look like? So my domain model looks like, I have a love and hate relationship with domain-driven design, right? So there are things that I like a lot, there are things that I hate, right? So I'll show to you some of these distinctions. So normally my domain model, the entry point to my domain model will always be what I call actions, which is just another name that I gave to something that already exists, that are the application services in domain-driven design. Exactly the same thing. I just prefer to call them actions because I don't like the three things called services. And I think that I'm more focused, and I'll explain why. But a domain service should provide, a domain model, sorry, should provide behavior to the external world, which means the external world will be executing actions. So find the book, make a payment, create this user. So all are actions. So I like to model my domain model with actions at the front, because then I can start having an idea of what the flows I'm providing to the external world. So the actions will control, or will control the flow, delegating behavior to different domain services. So if I want to deal with books and stuff, I'm going to go to the domain service. So that becomes, then you start having a notion of components. according to business terms, right? According to nouns, things that exist in your domain. One thing that changed for me a bit is repositories. In domain-driven design, when you talk about the building blocks, the repositories are a first-class citizen. So I don't treat repositories as a first-class citizen. I treat repositories as a helper, as a second-class citizen that is always behind the domain service, but only one domain concept can access a repository related to that domain concept. So in terms of, I will expand that a little bit. The interesting thing is that the interface of your infrastructure services and potentially repositories, they are part of your domain because they represent a concept. Sending an email is a concept, is a behavior that I want. Having a repository that can create, delete, update, find, whatever, books and users is also a concept. The implementation belongs to infrastructure because then I can have my Oracle user repository, I can have my SMTP email sender or whatever, right? So, but the interface belongs to the domain. One of the things that is quite hard in software design is deciding where the behavior goes, right? That's why you have all this anemic domain. You have things like, you have anemic classes, classes with stated no behavior, and classes that are God classes, full of, everything is in there, has no state, or has a state and behavior, and everything is there. So deciding where behavior goes is quite complicated. So I have a few guidelines. I don't follow rules, right? So, but I have guidelines in my head that I quite often break them as well. But like the guidelines are, my action classes, they will only, the behavior that they will have is anything that is related to controlling flow, but it won't do anything specific. It will always delegate, push behavior down. My domain services will concentrate their the behavior in a specific domain. It gets interesting when you talk about entities, and that's another distinction that I don't like what I see in domain-driven design today. Entities are at the core of domain-driven design. In my mind, every time there is a feature product owner or business to discuss a feature, we are talking about behavior. Oh, we need to allow the users to do that. We need to be able to sell these and make a payment and process a trade. And it's always verbs and behavior. So why are these two having a state as the core concept or model? So book cannot be the core concept, user or stuff. The core concept is like, I want to find books. I want to have my concepts, my main concepts as verbs and not nouns. So how do I split that? So entities will have attributes, they will have some state alongside their value objects. If the behavior is only related to the data that the entity contains, I will add that behavior to the entity. If the behavior that I want will go across multiple instances of the entity, or it will talk to external services or different parts of my business, I will push that up to a domain service. And if that will go across domain concepts, I will push that up to the action. That's normally the guidelines that I use. In domain-driven design, quite often they create a domain concept and they start plugging stuff into it. Everything that is user-related, you plug it in there. And then some people that are into domain-driven design say, no, but it's not exactly like that. We don't put all the behavior there. We put the methods, but the methods don't do anything. They actually throw a message that someone else will capture and then do that. Why would I do that? I don't get it. So, anyway. Repositories are interesting because I name them in a specific way. Like I like to use the plural. So for example, if I have user as the main concept, I'll call my repositories users. Sometimes the plural doesn't work. So for example, if you have books, in a certain context, the plural may be a library, maybe a shelf, or maybe just be books. So, but I will try to use to represent what that collection means. This is an example. Don't get too hung up because I just made that up, right? So for example, if you have like, you are on a web page, you have like a shopping cart and blah, 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 you went to the payment page, put up your payment details and say, pay. There's a single hit on the UI, go pay, and that will trigger this flow. So the make a payment action class, so I'll have a class called make a payment. it will control this flow. So then we start looking at the acceptance criteria for that behavior and say, what we need to do? Oh, we need to check the user account. Check if it's a prime or valid user, whatever. We need to call the payment gateway. The payment gateway may need to figure out which credit card processor. We need to keep on order history. We need to send an email. So basically, this is an action. 3 domain services. Domain services are not only related about entities. I don't have a user domain service so domain service is a concept, is a behavior, is an area, is a component that may or may not be persisted, that thing that it's related to. And then you have a few infrastructure services as the interface part of the domain model. So that's an example. So that led me to some insights. And that also comes to how I design and also how I test. I realized that the classes that are closer to the input of my application, let's assume that this is a controller, so the delivery mechanism is triggering my domain model. So the classes that are closer to the input of my application, they are in a higher level of abstraction than the classes that are inside my domain or towards the output of my system. So why this is important is because of, if you understand different levels of abstraction, for example, this class is responsible to trigger a flow. It will be like make a payment, process a trade. Processing a trade in an investment bank has tens of thousands of lines. So if the class that starts that flow cannot know detail, it's in too high level to know all the details. So I need to push behavior down. So as I'm going down, the classes are becoming, they become with a lower level of abstraction and more specific. So what does it represent in design and testing? Because there is all this discussion about, should we mock, should we not mock, should we use classes, should we use London School, outside in, blah, blah. It all depends, of course, because I'm a consultant, it still depends. But like, you need to understand levels of abstraction. If a class is in a higher level of abstraction, it means that it doesn't have low-level behavior. Which means that, what is the behavior? Controlling flow. What does it mean in terms of design? Collaborating. At this point, you are going to start thinking about outside in and mocking, because testing this class means when this class is triggered, make sure that it kicks off the user validation. If it's valid, you trigger to make a payment, and blah, blah. So it's all about collaborations. You're going to use more mocks in there, because we're making sure that the flow is correct. As you come down, it becomes like, validate this user, insert, parse this XML. It's far more, it's far in a much lower low level, and then you can click probably the lowest the level is, less collaborations it does. So then, probably the classicist approach will be a little bit better. Maybe. So you can flick with that. And end of code branch is the same. So code base has a branch, right? So, well, normally. So it goes in one direction, then comes back, and then triggers another one, then comes back. So this end of code branches is also quite low level, it doesn't collaborate, so you probably won't use mocks. So understanding that helps you to choose the right testing approach and deciding where the behavior should go as well. So a few guidelines that I use. Normally if there's a controller and talks to the actions, I don't allow actions to talk to each other. Because if that happens, it means that I'm missing an abstraction. So if there is something that should be shared between two actions, I will push that down as a domain concept. And then have the 2 points to the same domain concept. But I want my actions to be focused just to represent what is the behavior provided to the external world. Domain services can talk to each other. For them to do their job, they can talk to each other and ask for help. Never, a repository, as I said, I treat as a second-class citizen that is a helper, so it's kind of an internal. It's something that domain concept we will use to persist or to hold state, but I don't want anyone going there. With the exception for the read model. So those are guidelines that I use, but depending on what I'm doing, I also like the idea of CQRS. But CQRS not all the way through. I love if it's needed to go all the events and all the separate read models and separate database. If you need to go there, you go. But you don't need to go straight away. But you can still have that. So, why do I say that? The reason that I like the idea is that they use hibernate and hibernate, or that what's kind of crap. Now you don't want to raise your hand, right? So I use that a lot, of course, as many other developers. Very rarely you have objects that they live in isolation. That's why you wire all our entities with one-to-one, one-to-many, many-to-many, all this kind of stuff. But when you do that, it's because you want to query. When we want to update something, we very rarely update my profile at the same time that I post a comment, right? But if you have a social network for travelers, like I have a user, I have a profile, I have friends that are users, I have trips, trips have days, days have locations, locations have photos, photos have comments made by users that have friends. All of this is connected. And I may want to slice and dice this domain model according to the queries and page that I have. And that's why we connect them all. But I don't need that to update. But you really end up creating a much more complex domain model because of the multiple types of reads we want. But if I normally update one domain concept at a time, I don't need any of these wirings. But I still need my business rules. But if I have CQRS and I can, so for example, I have a write model that guarantees the invariant of my system with no dependence of anything, just go there, create this user, create this user, update that, process that. And then I can have a read model, as Felipe was saying. I can start with a materialized view, single database. Read model goes to the table, or write model goes to the tables. Read model goes to the same data store, in the same application, same deployable, but access directly through a repository, the materialized view, with denormalized data, and return exactly what I need for the query. So that, I don't have any wiring, I make both sides far simpler. And that's the only time that I will have an action going to a repository, and that will return a value object with denormalized data according to the view that I have. So that's what I normally do. So, okay, how does it look like then? In terms of, when I say package, it means the same thing as namespace in C#. I normally work with Java. So packages, so I normally start with my core, and this one would be my delivery mechanism. So I start with this, straight away with this structure. And so if I explore that, I'm hating this microphone. So if I expand that, the top level of my delivery mechanism and my core domain will have normally 3 packages. Infrastructure, model, and actions for my core, controllers, infrastructure, and view for my web, if it's a web, my delivery mechanism, right? So let's explore the delivery mechanism that is less interesting first, and then we go to the other one. So controllers should be thin. So let's get MVC straight. Controller should receive a request from the view, and the only thing that it does, because it already knows because it's mapped, is go to the model and say, do that for me. Model will do all the cool stuff and say, that's the result. Controller said, okay, either go back to the same page or go to another one, and that's your data. That's it. If your controller has more than 3-4 lines, it's definitely doing too much, right? It's definitely not following the original ideas of MVC. That's what a controller does. Redirect your model, get the result, back to view. That's it. So infrastructure, you need to parse your JSON, your XML, so there will be some infrastructure on the front, on the delivery mechanism as well. And you probably have some view models, validators, and all that kind of good stuff. And your static file. So not so interesting. Core domain. Let's assume that we are starting with a simple application. Infrastructure I'm going to cover later, but the main things are model and actions. The model, as soon as I open, I will name my package according to nouns. Every noun that is important in my system and has behavior attached to it will be represented here. So I have book, I have user. As soon as I open my model, I start having an idea of what the system is about. But I still don't know what it does. So in the actions, I will name my class with a mix of verbs and nouns, representing the trigger or the behavior that I'm offering to the external side, to the external world. So first I'll have classes named like add book to wish list, search books, update user. Because those are the triggers, those are the behavior that I'm providing to the external world. So if I open both, just these 2 packages that are very high level, I already start having an idea of what the system is about and what it does. I start having an idea what the books represent. So of course this will evolve. So as soon as it evolves, books were not enough. We introduced electronics. And then we need to go back to our product owner and say like, so books and electronics, are they similar? Are they the same level? Is there a higher level concept we can represent? Oh, we call them products. So we start refactoring our package structure according to the domain. We refactor a lot of our methods and classes, but very rarely we go to the core structure of our application and we keep refactoring them. And we need to. So we can start grouping. So payment. Payment is probably something that I don't persist. It's not about entities, it's about nouns that represent a concept in the application that has meaningful behavior attached to it. So payment is one of these things. But I probably won't have a payment entity. But I know that the system has payment. It's one of the things that the system does. And then, of course, that these actions will start growing. Right? As they start growing, you need to start clustering them. So you need to start finding, okay, so this is about user accounts, this is about purchase, this is about products. All of a sudden, you start having this idea, like, for example, you have user stories, normally they're more interesting projects, they will be part of epics and stuff like that. So you start mapping themes and epics in here. And you know what is interesting about this is, we talk a lot about microservice today, and then one of the challenges is how to split the behavior, because like if in a monolith, when you change a class, it may cause a ripple effect. At least, thank God, like some of us have IntelliJ, right? So that can deal with that or resharpen and stuff. But imagine a ripple effect across deployable units, across microservices. Screwing up all your APIs and deployables and stuff. Moving behavior around is not so easy. But if you can get to those behaviors in an evolutionary manner, you start having the notion of bounded context that a lot of people talk about in domain-driven design. Because you are gradually evolving your application, clustering behavior in a natural way, aligned to what the business wants, aligned to what the system does. And once these clusters, they get more mature, more important, more interesting, you may have a better way to extract that as a separate deployable, as a separate service. So this is a way that you can start migrating towards that direction. Will be that easy? Not quite, because you still are sharing some entities. Right? So there will be problems there. But at least you start having an idea of how your application can be split into different services, modules, in a more cohesive way according to the business. So the chances of having a massive ripple effect across your services will only happen if your business rules change dramatically, the structure of your business. So in terms of, if I look inside of my modules, I have my entities, aggregates, the repositories, services and stuff. One interesting thing, I completely removed any notion of layers from my packages or namespaces. Completely. I still have them here. I still have a thing called service. I still have a thing called, so there are, where's my book collection? In this case, I call it my repository. So the layers are still there represented by classes. But there's no notion in my structure because business-wise, layers make absolutely no sense whatsoever. They're only important for us to understand where the behavior should go, but there's no business meaning at all. So I just put everything together. That becomes a component, right? So I could also, it would be easier for me to extract. And then my infrastructure has all my MongoDB, these, GigaSpace that, and all my credit card processors and all kind of nonsense. So the interesting thing about this approach is that I learned that it's easier if you start designing from outside. Instead of how we used to do in the past, and people still domain design, not all, but some, they will say, oh, let's create in our aggregates, let's create these. Yeah, but to serve what? How the clients, how the external world will interact with this. Oh, I'm not sure yet, but we're going to get to that. But let's create this model. This is a thing that I completely deviate from the domain design. My entities are second-class citizens. I treat my entities as pure data structure, and they will emerge according to the behavior that I'm providing to the external world. First of all, it's like, what is the request? What the external world wants from my system? Because that's what I'm there to provide. Behavior, not to have an HT class, right? So as I create my action, then you say, which data do I receive? What we need to persist? And as I'm providing that behavior, my entities will emerge. But one thing that is interesting is, because I'm writing this class first to satisfy a need, every class should be created to satisfy, to serve a client class. So you never design a class in isolation, right? Because that would be a selfish class. I'm so important, that's my API, you deal with me. And then you have all these code base there are loads of bugs, because the classes were not designed to work, to serve each other, right? So they were created independently, and at some point you try to glue them together. So in this case, I will write the class to serve the external world. What the external world wants to send to me? What does the external world want as a return? So that's how the signature of this class will be. But this class is high level. It needs to do loads of stuff, so it needs help. So what are the things? So if I have an acceptance test, so as soon as I go make a payment, I need to validate the user. I need to call the payment gateway. I need to send an email confirmation. As soon as you start listing the things in your acceptance criteria, that behavior that you want as part of the acceptance criteria of this class, they are candidates for domain services, domain concept. So when I think about them, I will design them with an API to serve this class, because this class needs that behavior. So they will emerge to satisfy this one. These will emerge to satisfy this one. So the APIs, the code will always read nicely, because they were designed to serve. Right? So an interesting side effect of this is that there is an execution flow that is aligned to outside IntelliD, and that is aligned to the design flow as well. So they are all aligned. So we are always producing just what you need in the nice way possible. And once again, the focus will always be the behavior, and the data structures that you are going to persist or retrieve, they will emerge to satisfy that behavior. Not because they are important, like creating domains without knowing how they're going to be used, or creating entities without knowing how they're going to be used. So I think that I'm way over time, but so there is some notions of inner domain. I have this concept of inner domain, outer domain. If you need porting adapters and delivery mechanism outside, so that's how roughly that would look like. A lot of people talk about walking skeleton as well. So normally they say, oh, build a vertical slice of your system and then start building incrementally. This is nice for certain cases, but for example, I was doing web development. We found that not always, once again, those are guidelines. Remember that I said that not every single application that I use exactly that, right? But when we are creating web apps, sometimes the vertical slice, if you want to go from the UI until whatever persistence, you cannot go live halfway through. And also, it's not easy to understand everything that you need. And there are many changes, because if you are evolving your UI bit by bit, the terminology changes. So what we decided to do instead is, before we start doing the first vertical slice, do a very thin horizontal line where we just have the UI, HTML, CSS, and the page, mockups. So the business will look at, so if I click on this button, I go there, blah, 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 a small flow. Because when you start designing and seeing the UI, because you need to write what the buttons mean, what the text means in each part of the screen, the domain language starts flowing. Oh, we're going to make a payment in here. So now all of a sudden, now I have a noun, there's payment. Oh, we need to have the user this and that. So you start seeing that. And the business, as we are playing with the UI, this is constantly evolving. We're constantly renaming things and playing until you say, oh, that looks okay, so let's go with this for now. But at that point, with this thin horizontal line, that you can click and move to other pages, we flushed out enough domain language to understand how we're going to name things, and then we start putting the behavior vertically, bit by bit, and even hiding parts of that thing. So, because otherwise, just vertical slice one after another. In certain applications, we were doing many refactorings because the UI was also being done differently. The names were changing, and loads of changes were happening. You can parallelize that as well, blah, blah, blah. How many hours do I still have?
You can keep going for a bit.
All right, okay. I'll try to just at what time does the office close? All right, let's get on with it. So, testing. So how do you test it? That was important for me as well. So, and if you try to Google types of tests, you go crazy. There's integration, acceptance, journey, black box, end-to-end. What the hell does that mean? I don't know. Right? So everyone has a different definition of it. So I said, well, you know what? Screw that. I don't care. So what we decided to do is you go to the whiteboard now because we have normally a notion of how the application can be architected. And we go to the whiteboard, put the pieces in there, draw a line, and say, I would like to test this part in isolation. Draw a boundary there, how we as a team want to name that. And then we choose a name as a team. So if I say, like, we're going to have user journey test that is just navigation, everyone understands. I don't care what other people say or call in other companies, as long as my team understands the boundaries. So I want to test a full thing, from the action until the repository. I'm going to bring the persistence inside or outside. With the boundary, we decide. Do you want the whole thing, the database should be there, or outside and locked? There's no right or wrong answer. As a team, we say, that's the boundary that we want, give it a name. In this case, called acceptance. And then we keep going. Oh, but I want you to test my inserts, delete, queries, and stuff. Cool, let's just test the repository. What do we call? Call integration. I don't care, call it something else. But what is a unit? I don't care what other people call. For our team, a unit is a class or this group. So you can do that as well. So put a rough design of your application, put boundaries inside what you want to test and name. So end-to-end, blah, blah. Don't. Right? Just don't. So the thing is, this is all well and good until you use a big, massive framework. And then all of these goals are put in there. So in order for you to have the freedom to test the way you want, you need to be able to slice your application the way you want, which means that you need to control every single aspect of it. If it's a web app, I need to control how it's deployed. I have an option in Java world, the old way, create a jar or a war and deploy an application service, where I can embed Jet inside of it. And instead of having the thing deployed somewhere else, I run from the command line, because my application triggers Jetty and registers itself into Jetty. So that means that I can even call my application and say, mock my entire service. And then I can do any test that I want, because I control every single aspect of my application. And that's not a lot of code. I'm just talking about very few lines of code, at least in the Java world. Databases don't completely hibernate, all this kind of nonsense. For Java people, maybe that will make more sense. I went back to JDBC. Basically, just execute the commands against the database. Because then I'm free. Freedom. It's awesome. Right? I could not see that 10 years ago. And now I know how good that was. I control my transactions. I control which objects I return. If I want to cross data, if I just want to update, I control everything. Which means I can test whatever I want, because I control. So, yeah, never follow rules. All the things that I said, in certain contexts, are like, forget that, it's shit. Right? So, TDD won't lead to good design if you don't know what good design looks like. So I said that TDD leads to good design many times. I even wrote about that. I changed my mind. So it will only lead to good design if you know what it means. I'm not saying that I know, but we need to have a consensus within your team what it means, and then you may have a chance. But if you don't even understand all these design concepts out there, you will test drive crap. There's no doubt. So basically, as a summary, that's what it is. So model shows that I know what it's about. It's expressed by nouns. I have a bunch of actions that are more verbs. So I know what it does, what it's about. That's my book. And that's the drawing. Any questions? Yes.
Yeah, I would like to know if you have even played mixing up all the DDD building blocks and layer architecture, or DDD layer, sorry, with the AK actor system?
No.
Okay, so.
No. No, I didn't. Any other question? Beers? Drinks? Smoke? Yes. Just
I didn't see on the let's say the proposition you made where the transformation between one layer and another will process or will happen. I mean, on the action side, I suppose that you will receive.
I probably went too fast on that and I didn't expand much.
So maybe on the domain side, I understand that.
But just for me to understand your question, so you're asking like where the transformation goes from the model to the back to the delivery mechanism?
Or at the end from the action to a domain class.
Right, the action is already talking about the domain language. So the transformation happens before.
Okay, so
yes. This infrastructure here, so normally my controllers, what they will do, you know how they are mapped, because normally you associate a URL to a method, right? So you already know what you need. So you know normally, let's say that it's a JSON, just to simplify the answer. So a JSON will come in, it needs to become some domain object, should go to the domain. Domain will return object, won't return JSON for sure. And then it needs to be transformed that back. So this is like, so my controllers, besides invoking the method, the model, it will translate, but it will not translate within the controller method, but it will have a call to my infrastructure that I'll have all my XML and JSON parsers in there. So that I will get a JSON, so I normally call them whatever, user to JSON, user or something like that, and I can do to and from.
So at the end you have a kind of a huge package with all the transformation objects.
They may be huge, maybe not, but yes. So I will have enough, depending on the size of my domain and the type of transformation that I will have, but at least they are very isolated, and I stopped using, in the Java world, we use all annotations in fields, and because then you have like your domain entities, or your entities with annotations for the persistence, annotations for the JSON, and then someone decides to change a field, and then you break everything. So I don't do that at all. My entities don't have a single annotation, I do it by hand. I realized that it's actually not bad to write code instead of having some magic that does stuff for me, because controlling all the transformation gives me all the freedom not to take my domain, my entities, and create attributes in there just to satisfy the persistence, but now I need to disable them for persistence and all this kind of stuff. No, I do it by hand. Write code.
Yeah, but at the end I understand that you will lose, let's say, the power of this magic transformation, but you can be more flexible, no? Because you have more...
Yeah, I don't want this power. I prefer the flexibility because I can unit test that, and I can have the completely decoupled. So I can take bits of information from the model and generate a JSON in whichever format I want and do all the transformation and stuff, and vice versa. So I prefer the flexibility in this case. The other question? Yeah.
Where do you put your transaction borders?
So transaction borders are extremely interesting because, of course, it depends, right? So, but normally, so it may be that the best place to put them is inside my action. It's A. So A will, if that thing should be atomic, I will start transaction through the action, and in my domain services, I will also have a transactional thing that will say, if you are already in a transaction, don't start a new one, otherwise, start a transaction from here. So that's how I play with them. So if it's just important one bit, I push that down to domain service, otherwise I start up. But I always prefer transaction security stuff to push up. Always. Any other question? Yes?
What level of reuse is in this model, the domain?
That varies a lot. So in this case, I didn't build this with reuse in mind. I built this way in terms of understanding where things are and have movable parts. Reuse, you need to wait to see how the application evolves, and you may reuse a lot some classes and never others. But at least you give me an understanding where things are, and it's very easy for me to navigate. So that was my main motivation, not to reuse. Reuse is a consequence, if it's well split. That may or may not happen. Drinks? Smoke? All right, thank you very much.